Hello, my name is Michael Baumgartl and I'm a medical physicist, and I would like to present you a dose evaluation of films using an open source approach. As you all know, it is still common to use radiosensitive films for dosimetric evaluation of dose distributions in quality assurance. And the main benefit of that is the high spatial resolutions of the films. Many of us are very familiar with this user interface. It belongs to ImageJ, which is actually a Java-based imaging processing tool, and this provides all the basic features necessary for a decent dosimetric dose evaluations, for instance for Gafchromic EBT2 films, using the vendor's requirements. It is an open source tool, it is commonly used in research, you can write your own macros and plugins, and it is a cheap alternative to your commercial software. It is not supposed to replace your commercial software, but it is always good to have a secondary independent method to double check what you measured. Of course, you need some time to get used to this approach and all the features, and most of the commercial softwares, they do have more features available, for instance, gamma analysis and even more. But the necessary basic features as applying a Gaussian filter, splitting the channels, putting in some plugins, or even generate a calibration curve, it is all there. And I would like to show you how this can be done within minutes to have a reasonable result. Let us now evaluate this EBT2 Gafchromic film on the left side. It was irradiated with an orthovoltage unit. The shape of it is clinically right now not relevant, but what is relevant that you have such calibration films available with a known dose. So this one is 0 gray, 1 gray, and 2 gray. I also recommend before you start to download the plugin contour plotter and put it into ImageJ to generate actually such nice isodose lines. This is a different film put into an Alderson head phantom, and here you can see the isodose lines indicating a nice dose gradient, and you also have very smooth isodose lines because a Gaussian filter was applied. As a second step, it is necessary to split the channels of your image first before you start, because the recommended method to evaluate this film from the vendor is to use the red channel method. As mentioned already, you can apply a Gaussian blur to make the isodose line smoother, and you also can set the scale to measure certain distances on your film. Your final task would be to generate a calibration curve. How can this be done? You choose the icon rectangular and you set a box on your calibration film. You press Ctrl M and you repeat it for all of them. And then you have the mean gray values, which can actually be assigned to your known dose. You enter Analyze, Calibrate, and then you assign those values, the mean gray values, to your known dose. You need a certain function, and now the problem is that the function which is recommended from the vendor cannot be put in there, so you cannot use a user-defined function. Only this Rothbard function is available, but it will do the job, and I will show you why. Gafchromic is actually recommending this rational function, but as you can see, compared to the Rothbard function down here, there's not a big difference. You can go for a workaround if you still want to stick to this rational function and use the curve fitting tool. You open it and define this rational function, save the text file, and reuse it for your calibration curve. Once you've completed the previous steps, you can start with the evaluation. On this slide, you see a comparison with the commercial software called FilmQA and the ImageJ approach. It's a PDD of 6 MeV electrons, and one could say that the results are quite comparable. And to conclude, I would say that this approach is a very decent independent method to double check your current approach, your current software. Thank you very much.